Hello everyone, this is Yash Nama. Thank you for joining me on this video. Today we will go through a case study on a make or buy decision using cost accounting concepts. PH Limited produces and sells 4 products A, B, C and D. The estimated demand for 2021 for the 4 products, their selling prices and variable costs are as follows. So we've got the annual demand, selling prices, direct material cost per unit, direct labor cost per unit and variable overheads per unit for each of the 4 products. The variable overheads are absorbed on a machine hour basis at a rate of $1.25 per machine hour. Fixed overheads amount to $4.486 million per annum. The production capacity is 875,000 machine hours per annum. Products A, B and C can be bought from external suppliers at 21.36 per unit, 24 per unit and 48 per unit respectively. Requirement A. Determine the contribution per unit, machine hours per unit and total machine hours for the year for each product. So let's take a look at this. The selling prices are 24.88, 29.68, 56.08 and 48.88 respectively for A, B, C and D. Then we move on to variable cost per unit. Here we have 3 variable costs: direct material cost per unit, direct labor cost per unit and variable overheads per unit. So selling price minus the sum of variable cost per unit will give us the contribution per unit. Now this addresses the requirement of determining the contribution per unit. The next one is to determine the machine hours per unit. In order to do that, we will make use of the rate per machine hour. In the question, we are told that the rate per machine hour is $1.25 per hour. So, variable overheads upon rate per machine hour will give us the number of machine hours per unit for each of the 4 products. So here we have the annual demand for each of the 4 products. We multiply the annual demand with the machine hours per unit in order to determine the total machine hours required for the year for each of the 4 products. Let's move on to requirement B. Determine if there's any limiting factor which would limit the production capacity for PH Limited. Now the total machine hours required to meet the annual demand is 917,000 machine hours. However, the company has a total production capacity of 875,000 machine hours per annum. Since the total machine hours available are less than the total machine hours required in order to meet the demand for the 4 products, this means that the machine hours is the limiting factor. Requirement C. Determine the best product mix that PH Limited must produce in-house for the year 2021 and the resulting optimal profit. Let's take a look at this. So now that we've determined that machine hours is a limiting factor, we can now move on to determining the best product mix for PH Limited that must be produced in-house. Now to start with, we know that products A, B and C can be bought from external suppliers. However, product D cannot be sourced from external suppliers. Hence, product D must be produced in-house. So of the 875,000 machine hours available with PH Limited, 189,000 machine hours will be allocated to produce product D. So after giving 189,000 machine hours to produce product D, the company would be left with 686,000 machine hours. And now we have to determine how do we allocate these machine hours to products A, B and C. Firstly, we will make note of the buy-in price for the various products A, B and C from external suppliers. Product A could be sourced at 21.36 from external suppliers. Product B can be sourced at $24 per unit from external suppliers, and product C can be sourced at 48 per unit from external suppliers. Now the total variable cost of producing these products in-house are as follows. The variable production cost of product A in-house is 15.66, product B is 18.78, product C is 39.7. Next, we will try and determine what is the saving in cost by producing in-house. So now we see that we save $5.70 by producing product A in-house per unit. Product B we save 5.22 per unit by producing in-house, and product C we save $8.3 per unit by producing in-house. Now in order to produce product A, we require 1.2 machine hours. So if I divide the savings per unit divide by number of machine hours required to produce that unit, we will get the savings per machine hour. So for product A, we save $4.75 per machine hour by producing in-house. For product B, we save $4.35 per machine hour by producing in-house. And for product C, we save $4.15 per hour by producing in-house. So now we are able to rank the three products based on savings per machine hour. Product A provides the most saving per machine hour, followed by B, and C provides the least savings per machine hour. The remaining machine hours that we have after producing product D are $686,000. These machine hours will be allocated in this priority: product A first, then product B, and if we have any hours left, then that will be used to produce product C. So we have 686,000 machine hours left after producing product D. In order to produce product A, we need 150,000 machine hours. After producing product A, we will be left with 536,000 machine hours. In order to produce product B, we need 228,000 machine hours. After producing product B, we will be left with 308,000 machine hours. In order to meet the full demand of 175,000 units of C, we need 350,000 machine hours. However, we are only left with 308,000 machine hours, and each unit of product C requires 2 machine hours to produce in-house. So with 308,000 machine hours, we are able to produce 154,000 units of product C. So now let us look at the profitability for PH Limited if we allocate the machine hours in the manner we have done. So sales revenue for product A will be 24.88 selling price times annual demand 125,000. 3.11 million is the sales revenue for product A. For product B, the sales revenue is 5.639 million. For product C, the sales revenue is 9.81 million. And for product D, the sales revenue is 5.13 million. Now variable cost. Product A is completely manufactured in-house, so the variable cost for product A will be the sum of the material, labor and overhead costs times the annual demand. Product B is also completely manufactured in-house. The variable cost is 3.56 million. Product D is also completely manufactured in-house. The variable cost is 3.52 million. For product C, 154,000 units are manufactured in-house. So 154,000 units times the sum of material, labor and variable overheads. So that's the variable cost of producing in-house, and the remaining units are sourced externally. So the total demand for product C is 175,000, out of which 154,000 units are produced in-house. So the remaining units are sourced externally at a cost of $48 per unit. So this is the cost of sourcing from external suppliers for product C. So contribution is sales revenue minus variable cost. So the total revenue is 23.695 million. Total contribution is 7.5 million. The fixed cost is 4.486 million. and the operating profit will be 3.03 million. I hope this video was useful. Thank you very much and goodbye.